We now turn our attention to a new notation known as factorial notation. By definition, in factorial, even though we see an exclamation point, we call that factorial. N factorial is equal to n times n minus 1 times n minus 2 times each whole number below it until you get to 1. If you have 4 factorial, for example, that is equal to 4 times 3 times 2 times 1, which is equal to 24. And if you have 6 factorial, that will equal 6 times 5 times 4 times 3 times 2 times 1, which is equal to 720. We always are multiplying whole numbers. We cannot ever have a 5.5 factorial multiplied by 4.5, etc. And you can never have a negative number factorial, because when you start subtracting 1, you'll never get down to 1, which you need to. So these are for whole numbers only. By definition, 0 factorial is equal to 1, and that is needed for definitional purposes, so we do not divide by 0. Now, you do have a key for this on your calculator. Most of you do, at least. And it usually looks like an n factorial. Sometimes it is on your main keyboard above some of your other keys. Sometimes you have to go into a probability menu. Some of you have a PRB button, which you will need to type on your calculator. And inside it, you will see n factorial as one of your choices. Now, let's evaluate 10 factorial divided by 6 factorial times 4 factorial. This is equal to 10 times 9 times 8 times 7 times 6 times 5 times etc. divided by 6 times 5 times etc. times 4 times 3 times 2 times 1. Now, we usually don't write etc. all that often, but the 6 and below will cancel from the numerator and the denominator, and that's why it was convenient for me to use etc. Now, let's do some other cancellation. The 4 will cancel with the 8, giving us 2. The 3 will cancel with the 9, giving us a 3 up in the numerator. And then 2 will cancel with the 10, giving us 5. So we could multiply together all that is left. I have 5 times 3 times 2 times 7 up in the numerator, and that is going to give us a product of 210. Or you could do this on your calculator. Now, let's do this using factorial notation that is more algebraic in nature. We are going to have n minus 2 factorial divided by n factorial. But n factorial is n times n minus 1 times n minus 2 times all of the whole numbers below it, which basically can be represented by n minus 2 factorial. So I can basically cancel those with each other and have as a result that this expression is equal to 1 over n times n minus 1.